Hello my dear friends and students, this is Sir Palmath and welcome to my video channel. In this video, we are talking about the fundamental counting principle. And this is your lesson, a part of your grade 10 mathematics lesson. Let us begin with our learning objectives. First, we are going to apply the fundamental counting principles in different real-life situations. And second, you are going to solve the possible number of ways or outcomes in solving problems involving fundamental counting principles. So this is our learning objectives for today's lesson. So my dear friends and students, are you ready to listen and to learn more about fundamental counting principles? Let us start. Let us discuss all about the fundamental counting principle. So what is a fundamental counting principle? A fundamental counting principle states that if one thing can occur in P number of ways, then the second thing can also occur in Q number of ways, and another thing can occur in R number of ways, and so on. The number of possible ways or outcomes can occur in whole number of things is, we have the product of P times Q times R times S and so on until you reach the last number of things can occur in last number of objects, which is letter Z. These are the product of all possible ways. Meaning to say, in this counting principle, we are using multiplication method of counting in order to easier to determine the total number of possible outcomes in such many group of objects. To determine the number of possible ways depends on the real-life situation using the fundamental counting principle. Let us discuss to you some of your illustrative examples on how to solve and determine the number of outcomes using the fundamental counting principle. Let us begin with our illustrative example number 1. So we are using the tree diagram and fundamental counting principle to consider to solve the given problem. A family has 4 children. So draw a tree diagram to show the possible genders of the children. So my dear friends and students, to solve this problem, here is the solution to the given problem. So we have stated the given problem above. So a family has 4 children. So we'll be going to draw a tree diagram to show the possible genders of the children. So we have the table shows we are using the 3 diagrams. So we have guided the first child, the second child, the third child, and the fourth child. And we have put the last column, we have the possible outcomes. So how will you make a tree diagram to produce some of the possible outcomes or the possible genders of among the 4 children? So in first child, we have the boy and a girl. So after the first child, it could be predicted it might be a boy and a girl also. So same with a girl. So it can be predicted might be a boy and a girl also. For the second child, the boy, it could be boy and girl also. The third child, same with the girl and the second child. Of course, all the outcomes. So there are only 8 outcomes in the third child. And it repeats until the fourth child. So these are the possible outcomes are the following. So for the first outcome, we have the boy or the first child, second child for the boy, for the third child also a boy, and fourth child is also a boy. So the possible outcomes is boy, 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 boy. Also we have the girl, so girl in the first child, girl in the second child, girl in the third child, and girl for the last child. So the possible outcomes of the last outcome is girl, 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 girl. Okay, so in this explanation about the tree diagram, So it shows that the possible genders of the children with a family with 4 children. So again, the first outcome, boy, 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 means the first child is a boy, the second child is a boy, the third child is also a boy, and the fourth child is also a boy. The last outcome, G, 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 means the first child is a girl, the second child is a girl, the third is also a girl, and the fourth is a girl also. So by reading along the branches, we get the possible outcomes by counting all the possible outcomes. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. There are all 16 possible outcomes of their genders among the 4 children. Okay, so that is, we are represented the tree diagram to determine the possible genders among the 4 children. Okay, so my dear friends and students, there is also an alternative solution. So, likewise, in a given tree diagram, the number of possible outcomes can be obtained by finding the product of possible outcomes in every event. So, in this alternative solution, we are using tables in order to ask to determine the number of possible choices in every event. So, in every event, and of course, we put the last column, which is the possible number of genders in all. So let us start with event letter A, which is the first child. We all know that on the first child that you born, it might be a boy and a girl. Meaning to say, there are only 2 choices. Why? Because the 2 choices we can be predicted might be a boy and a girl. The next event would be the second child. So if the mother can give birth for the second child, there are also 2 possible genders. It might be a boy and a girl also. So we have second child, which is 2. So same with the third child, he gave birth, might be a boy and a girl also. There are 2 possible choices. And lastly, we have also 2 possible choices for the fourth child. So to determine the possible number of genders, we are applying the fundamental counting principle. So again, by defining the fundamental counting principle, we are using the multiplicative method of counting. So what are going to do all of these number of possible choices in all events is to get the product of these all possible choices in every event. So we have 2 times 2 is equal to 4. 4 times 2 is also equal to 8. And 8 times 2 is also equal to 16. So there are only total number of possible genders, which is 16 ways. So we can rewrite as 2 times 2 times 2 times 2, or the exponential form is 2 to the 4th power, or 16 ways. And that is our answer to this given problem. So comparing with that with the tree diagram, and we are using the tables, so it is easy to use our alternative solution to use the tables in determine the number of possible outcomes in the given event. So that is our final answer. So let us proceed to our next illustrative example number 2. Okay, so it's snack time. Remwell's Refreshment and Cafe offers the following choices on the right for their snacks. So we have the different choices of sandwiches. We have the hamburger, the chicken, the egg, and tocino. And of course, we have the different choices of beverages. We have the juice, the coffee, and the soft drink. So suppose you choose only a sandwich or a drink. So my dear friends and students, the question is, how many possible outcomes are there? So my dear students, to solve this problem, here is the solution to the given problem. So we are going to use a table to solve the problem using the fundamental counting principle. So we have the given choices of sandwiches and beverages on the right side. So we are going to use the table to solve the problem. So we have the 2 events. We have the choices of sandwiches and the choices of beverages. And of course, we have the last column. We are looking for the possible number of outcomes. Okay, so to determine the number of possible choices in every event, So let us start with letter A, which is sandwich. We all know that there are only four choices of sandwiches. We have the hamburger, the chicken, the egg, and tocino. So we are only four choices. For the beverages, we have the juice, the coffee, and soft drink. So we are only three choices. So to find the possible number of outcomes using the fundamental counting principle, so we get the product of these two choices in every event. So we have 4 times 3, so we get 12 ways. So therefore, there are 4 times 3 or 12 possible outcomes, and that is the final answer to the given problem. Choosing the sandwich and the beverages for a snack are called independent events. So because one choice does not affect the other. So let's go back to the given problem. So we all know that the different choices of sandwiches cannot affected to the choices of the beverage. For example, hamburger is one type of the sandwich. It's a kind of food. But beverages is a kind of drinks. So hamburger does not belong to the beverages, meaning to say it is independent because in every choices of the first event does not affect to the choices of the other event. So we clarify that the independent events because any choice of the one event does not affect to the other. So now you know on how will you to define independent events. So there are sometimes in the every problem using the fundamental counting principle, we are using the dependent events. So what is the difference between the dependent and the independent events? So let us discuss the difference between these two terminologies. Two events A and B are called independent events when the occurrence of event A does not affect the occurrence of event B. So this is an example of the choices of sandwiches and the beverage as we have already discussed the problem earlier. So it doesn't affect the choices of the other. While two events A and B are called dependent events when the occurrence of event A does not affect does affect the occurrence of event B. So these are the example of the dependent events is we are looking for the possible number of genders among the 4 children in the family. So dependent events could be affected in every event. For example, when you give birth on the first child, so it might be a boy and a girl. So on the next child, we gave a birth, it's also a boy or a girl also. So meaning to say, the first event, we have the firstborn child, we are looking for the choices might be boy and girl is affected to the other event. So at the same choices. So what you know that my dear friends and students, the difference between these two. So that is dependent and independent events. So let's move on to the third illustrative example number 3. So true or false. There are only 10 items in the true or false test in the mathematics quarterly test. The question is, how many different choices for answering the 10 questions are possible? So my dear friends and students, to solve this problem, here is the solution. In every item, there are only 2 possible choices. So what are those 2 possible choices? We all know that the choices are true or false. So we take note, my dear friends and students, in every item number, it could be answerable with true or false. So by the fundamental counting principle, we have used the table. So the table using the row, which is the item number. So item number 1, number 2, number 3, until you reach to number 10. Suppose you will be answering item number 1, so that the choices are possible. We are using true or false. So we are using 2 choices on the first item number. Next is, suppose you will be proceed on the next item number, and you will be going to answer at the same manner. We are using the choices true or false. So there are only two choices. Same with item number 3 is also 2 until you reach to number 10. So we have the number of choices which has the product. We have 2 times 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 2. So we get a product of 1024 ways or different answers or choices. So in answering the 10 item true or false test. So my dear friends and students, so that is our answer. So let us proceed to the fourth illustrative example. Okay, that is our letter code problems. Using all the letters of the English alphabet, how many 3-letter codes are possible if repetition is permitted? So to solve this problem, here is our solution. Okay, so we have 26 letters in a given English alphabet. So since the repetition is permitted, you can allow to use these letters again at the same if necessary. So if the fundamental counting principle is applied, we have to use the tables in order to us to clearly understand, to illustrate the number of choices in every letters. So to determine the number of possible codes in forming using the English alphabet. So the first letter, we put one letter, a single letter. So there are only 26 choices. Because there are only 26 letters, it might be to use A, B, C, D, E until you reach up to Z. Okay, since repetition is permitted, you can allow to use these letters again at the same time if needed or not. So among these 26 choices, the second letter will be chosen only 26 letters. So it's still the same. So it could be use the letter again. Also with the third letter, so same rule, repetition is permitted. So we have 26 choices in all. So to simplify these 3 products here, or the 3 different choices, to determine the number of possible outcomes, we have the product which is 17,576 codes or 26 cubed. So we simplified 326 here. So 26 raised to the power of 3 in exponential form. So that is our answer to the given problem. So my dear students, let us proceed to the next illustrative example number 5. Okay, we have the plate numbers. A special plate number is made up of 4 letters of the English alphabet and followed by the 3-digit numbers. The question is how many plate numbers are possible if the letters and digits cannot be repeated in the same plate number. It's just like an example, the plate number is LOVE 143, which is love 143. To solve this problem, here is our solution to the given problem. So my dear students, there are 26 letters in the English alphabet that we are using the letters from A to Z, and 10 digits that can be used from 0 to 9. It can be formed in the plate number. Since the letters and numbers cannot be repeated at the same time in the given plate number, and the first letter has been chosen, it cannot be chosen the same letter over and over again. The same is true for the digits. After the first digit has been chosen, it cannot be chosen over again. So by illustrating the given table, so to clearly understand the number of possible choices in every letters and numbers. So let us start with the first letter. So there are only 26 choices in all starting from A to Z. So there are only 26. And suppose you choose letter L as one of the letter on the first letter. So we put letter L in the first letter. So there are, how many letters are left? So there are only 25. Why? Because letter L cannot be used all over again. So if there is repetition, is not allowed. So except from letter L, there are only 25 letters to be chosen on the second letter. How about the number of choices on the third? So we suppose you choose letter O as the second letter. So there are only two letters, we have L and O. So except of that, there are only remaining 24 letters to be chosen. Okay? So 24 letters. Suppose to choose the third letter is letter V as victory. So L-O-V. So 3 letters we have already chosen. So we put on the last letter in the given plate number, there are only 23 choices because we have already chosen the first 3 letters. So we put letter E, and that is the word love, L-O-V-E. So there is no problem. How about the numbers? So since we put the first number, there are only 10 digits can be chosen to put on the first letter. So from starting the digits from 0 to 9. Suppose you put you choose a number should be put on the second digit. So for example, we put number 1. We have already chosen number 1, and then there are only remaining 9 choices in all. So 9 choices we have because we have already selected number 1. Okay, we chose number 4 as the second digit. So there are only 2 digit numbers already mentioned. We have 1 and 4. Suppose we choose the last digit. So the last digit, there are only 8 digits left to be chosen. So we put number 3 as the last. So at least we completed yet forming letters and numbers on the special plate number. So LOVE 143. Okay. So after that, we have already filled in all of these possible choices in every letters and numbers. So we get the product using the fundamental counting principle. So by the use of the scientific calculator, or we use to solve manually, we have 26 times 25 times 24 times 23 times 10 times 9 times 8. So we have 258,336,000 number of special plates. So there are many special plates should be created. So that is our answer. So my dear friends and students, let us proceed on the next illustrative example. Okay, let's play the game. 5 cards are drawn from a standard deck of cards. Suppose that you are choosing 3 black cards and 2 red cards. If exactly one of the red cards is a face card, the question is, how many possibilities are there? So to solve this problem related to playing the game of cards, so here is our solution to the given problem. So here is our solution. Okay. We explained that there are only 52 cards in a standard deck. So all in all, 52 cards. So there are 52 cards which is divided into 2. So they classified as the color. So we have 26 are red and 26 are black. In every color, we divided also into 2 according to their shapes. So on the red cards, there are only 13 hearts and 13 diamonds. Among the 26 black cards, which is divided into 2 shapes, of course, there are only 13 spades and 13 clubs. Also, among of these 52 cards on the deck, there are only 12 face cards. Okay, my dear students, why is it there are only 12 face cards? Because the face cards are the king, the queen, and the jack. Of course, there are only 3 face cards in every shapes. So there are only 4 shapes, the diamond, the heart, the clubs, and the spades. So meaning to say, we are using the fundamental counting principle again. So 3 face cards times the 4 shapes. So we have 12 face cards in all. Okay? So to solve this problem, we are using the table to determine the total number of possible outcomes. So we explained that for the 3 black cards are drawn, there are 26 for the first choice. So in the first row, we put 26 choices of black cards. Suppose you choose for the second row of card. So there are only 25 for the second row. Suppose to choose another black cards again for the third card. So to complete the 3 black cards, we have only 24 possible choices of cards for black cards. So there is no problem. We have the 3 black cards are complete. So 26 times 25 times 24. Okay, next is you're supposed to choose 2 red cards, and one of them is a face card. So let us begin with the first choice is a face card. So among of these red cards, we use the face card, which is only 6. Okay, my dear friends and students, why is it there are only 6 cards on the first choice? Because among of these red cards, we are using the hearts and the diamonds. So 3 from hearts and 3 face cards for the diamonds. So we have 3 times 2, so we get 6. Okay, next is the second choice. So except among the choices using the face card, so which is exactly 1, the remaining cards starting from the ace going to number 10. So there are only 20 because there are only 10 numbers from the ace going to 10 times 2. So there are only 2. We have the hearts and the diamonds. So that is 20. So by the fundamental counting principle, so we get all of this product of this among different choices. So 26 times 25 times 24 times 6 times 20. So we get the product which is 1,872,000 possible outcomes. So that is our answer. So let us proceed on the next illustrative example number 7. That is the forming digit number problems. This is the first problem in the given forming digit numbers. So using the given digits available, which is 2, 3, 5, 6, 7, 8, and 9. So there are only 7 digits in all. The question is, how many 4-digit numbers are possible if letter A repetition is permitted and letter B repetition is not permitted? So we use the terminology, the word permitted, which is allowable. Okay? So to solve this set of different problems here, so let us present to you some of these solutions. Okay, let us start with letter A. We all know that there are only 7 digits available from 2, 3, 5, 6, 7, 8, and 9. So if repetition is permitted, so we can allow to use every digits at the same time in every place values. So in this table, we have the row of place values. We have the thousands, the hundreds, tens, and units. So there are only 4 digits should be formed. And the last one is the product, which is the number of 4-digit numbers. So the number of choices should be put on thousands place, which is 7, because 7 digits are available. So on the thousands place. So if the given condition is repetition is permitted, so you can allow to use among the 7 digits again and again. So there are only 7. At the same time, it might be, if necessary, to use any digit could be put on the tens place. So there are only 7. Same with the units. So we get the product, which is 7 times 7 times 7 times 7. So which is 7 to the 4th power, or 2,401. 3 are 4-digit numbers if repetition is permitted. Okay, let us proceed to the second set of problem. Repetition is not permitted. So meaning to say, in this condition, you cannot allow to use any digit again and all over again. Okay? So we are using the table of place values to present to the given problem. Is not permitted. So in the thousands place, we use 7 digits. So 7 digits are available all in all. So once you choose any digit that should be put on the thousands place, so it cannot be used it again and over again. So except one of the digits you have already chosen, there are only 6 because repetition is not permitted. So if one digit should be chosen at the same, we have on the hundreds place, so there are only 2 digits are already mentioned. So we have except that of these 2, so out of 7, so minus 2, we get 5 choices left. So repeats again and again, it becomes 4. So 7 times 6 times 5 times 4, so we get the product which is 840 4-digit numbers that you formed in this problem. Okay, so let us proceed to the last illustrative example. Illustrative example number 8. Forming digit number problems. This is the second set of problems. So, using the digits from 0 to 9. The question is, how many 5-digit numbers are formed if the specific condition is letter A, repetition is permitted. For letter B, repetition is not permitted. Letter C, even and repetition is not permitted. Letter D, odd number and repetition is permitted. And letter E, repetition is not permitted. The digit starts at even number and a multiple of 5. So my dear friends and students, so to solve these different sets of problems in this illustrative example, so hereby present to you some of their different solutions. So our solution, let us begin with letter A. So we all know that there are 10 digits available using the digits from 0 to 9. So from 1 to 9, and we added plus 1 becomes 10. Okay, we include the 0. So if repetition is permitted, it could be used any digits again and all over again. Okay? So by representing to use tables by its corresponding place values, and we put the different number of choices in every place values. So let us consider the given number of digits in every place values if there is a restriction or exceptional. So let us start with the 10,000s place. So among of these digits on 10,000s place, we all know that cannot put 0 on the 10,000s place. What is the reason? When you put 0 on the 10,000s place, can you imagine? So when you put 0 and we put any digits here, for example 0, 1, 2, 3, 4. Imagine 0, 1, 2, 3, 4. It cannot be read as 0, 10,000s, 1,000. So which is wrong. So it could be instead of 5 digits, we are forming 4 digits because the first digit among the 10,000s place is 0. So which is wrong. Okay, so what we're going to do on the 10,000s place, we accept 0 on the 10,000s place. So among of these 10, we subtract 1 except 0. So we have only 9 choices should be put on the 10,000s place. Let us proceed to the thousands place. So in this case, we choose any of these digits, and of course 0, we can be allowed to choose 0 on the thousands place. So in between of them, so we use 10 digits in all because repetition is permitted. Same with manner with hundreds place, of course 10 thousands place or 10 place, repetition is also permitted. And for the ones place, we use also 10 digits in all. So we get this product, we have 9 times 10 times 10 times 10 times 10 by the calculator. So we use 90,000 5-digit numbers if repetition is permitted. So let us proceed to letter B. How about repetition is not permitted? So we are using the same table of place values, and we all know that on the 10,000s place, you cannot put 0 on this place value. So except from 1 to 10 or from 0 to 9, we accept 0 on the first digit. So we have 9. So accept 0. After that, on the 10,000th place, in this case, repetition is not permitted. Oh, for example, we have when you choose one among of this digit is 2, so we put 2. And of course, we accept 2, so there are only 9 remaining. And of course, 0 should be used from thousands place, so it's allowable. So among of one choices that we chosen on the first digit, so we accept 2, for example 2, so it becomes 9, of course, because we bring back to choose 0 on the of the thousands place if necessary. Okay, let us proceed to the hundreds place. So we have also 8 because repetition is not permitted, of course 7 and 6. So we get the product of these numbers. So we have 27,216 ways or 5-digit numbers can you form if repetition is not allowed. Okay, let us proceed to another set of problems. So letter C. What if it is even and repetition is not permitted? Okay, so we use the same table again, and we can analyze in every place values. The number of possible choices should be chosen in every place values. Okay, let us start with the 10,000th place. So we all know that we cannot put 0 on the 10,000th place. So except 0. So there are remaining 9 digits should be chosen on the 10,000th place. Okay. So for example, we choose 1 as the 10,000th place. So we accept 1. And of course, we include 0 because you can use on the thousands place or any place values except the first digit. So among this one, 1 is except, so there are only still 9 digits in all. Okay, after 9 digits, so since repetition is not permitted, so minus 1, so we get 8. And after that, we have the 10th place is 7. Okay, how about 1's place? Let us analyze. We all know that the even numbers, so even numbers are just a multiples of 2. So that based on the divisibility rule of 2, it is an even number and it could be on the last digit is 2, 4, 6, 8, and 0. So we all know that the even numbers, which is 5 only. 5 even numbers. We all know that even numbers are 2, 4, 6, 8, and 0. So that is 9 times 9 times 8 times 7 times 5. And we have the product, which is 22,680. So by using the calculator. Okay, how about letter D? It is an odd number and repetition is permitted. So in this case, we can use any digits if repetition is allowable. So let us use the place values, the same table all over again. So we all know that you cannot put 0 on the 10,000th place, so we use 9 digits. And then, since repetition is permitted, so we use that 0 on the thousands place until you reach the ones. So it might be the answer is 10. Okay, so 10 digits since repetition is allowable. Okay, also we have the hundreds place is 10, the tens place is 10 also, and ones place. Okay, the ones place is 5. Okay, why is it 5? We all know that the odd numbers are just we added 1 or subtracted 1 from the even. So it which ends with 1, 3, 5, 7, and 9. So there are only 5 odd numbers in all. So we have the product, which is 9 times 10 times 10 times 10 times 5. So we have 45,000. Okay, let us proceed to the last set of problems in the given illustrative example. Okay, letter E. It is repetition is not permitted. The digit starts at even number and a multiple of 5. Okay. So we all know that we cannot put 0 on the 10,000th place. So we use the table again. So let us analyze. On the 10,000th place, we all know that the digit starts at even number. And of course, 0 is not included. So 2, 4, 6, 8, and 0, so we accept 0. So among the 5 even numbers, so we use 2, 4, 6, and 8. So we have 4 digits should be chosen on that 10,000th place. Okay, let us proceed to thousands place. So, if repetition is not permitted, so it might be we can use all of these digits on the thousands place. So, um, so we have repetition is not permitted. So if any one digit number or one of any digit from the event 2, 4, 6, 8, and 0, so we can use the 0. So we have 9. Okay, so 9 except the one number which will be chosen at 10,000 place. So repetition is not permitted. So 9 minus 1 have 8. 8 minus 1 is 7. And for the ones place, we all know that the ones place, which is a multiple of 5. We all know that the multiple of 5, which ends at 5 and 0. So it is based on the divisibility rule of 5. So 5 and 0 is the last digit. It's the multiples of 5. So that is only 2. So we have the 5 and 0. And that's the time to get the product of these all possible choices in every place values. So 4 times 9 times 8 times 7 times 2 by the using the calculator, so we get 4,032 possible choices. So that is our final answer in the given set of problems in this illustrative example number 8. So my dear friends and students, so I hope that you really understand some of these terminologies to remember that we are pertaining to the fundamental counting principle, and as well as some of their illustrative examples we have represented all of these on how to solve using fundamental counting principle. So my dear friends and students, so that's the end of our video channel for today's lesson. So my dear friends and students, so thank you very much for watching. So God bless us all. So let us follow, like, share, and subscribe Sir Palmath TV, my YouTube channel. So hit the notification bell. So thank you very much and God bless us all.